Lesson number 2 is all about triangles. And identification or classification of triangles will have a great impact on the possible solutions, topics, concerns with triangles later on. So we need to first identify the relationship between the classification of triangles in terms of angles and sides. So for items 1, 2, 3, 4, and 5 here, we just need to determine whether the statement can be true or false. So we are going to determine if a triangle could actually uh, um, have the two characteristics stated per each of the statements here. Let's try to analyze them properly. Let's talk about number 1. A scalene triangle can be a right triangle. In trying to determine what is the truth value of each of the statement here, specifically for number 1, look at the two triangles being described. It states that a scalene can be a right triangle. Now, a scalene triangle is a classification of a triangle according to sides. According to sides. And the right triangle is a triangle classification according to angles. As we can see, there is no conflict between the two, okay? Because the first classification is in terms of sides, and number 2 is in terms of angles. If we could actually look at this, we have here a possible example with this figure here, okay? And let me write here notation. So for this triangle here, it is a right triangle because it has this notation here. And look at the sides. We have the shortest side, and this will be the medium length probably, and this is the longest side. As you can see, it is a right triangle and the sides do not have the same measurement. So that would mean that these two classification or characteristic could be a characteristic of one triangle. So to answer number 1, a scalene triangle can be a right triangle. They could go together. The answer here is true. The answer here is true. How do we determine if it's true or false, sir? Look at again the classification of triangle stated per each item. If they do not overlap, it is not, if there's no conflict between them, the answer is true. If there is a conflict between them, that would be false. Let's look at number 2. In number 2, it is classified or stated as an obtuse triangle can be an acute. We have here obtuse triangle, and we have here acute triangle. Now, an obtuse triangle is a type of triangle or classification of triangle according to angles. Acute triangle is also a classification according to angles. Look at the difference of the two, or comparison, or similarity rather of the two. They are both classifications under type of angle. Take note that if you talk about obtuse triangle, one of its angles is an obtuse. So that possible form here for number 2 is this and this one. It has an angle which is an obtuse angle. Okay. But if we talk about acute triangle, it is a type of triangle wherein all of its interior angles are acute. Yes, this is acute. This is acute, but the last angle is obtuse as it is what is given for the first consideration. This would mean that there is a conflict between the two statements because both of them are under the classification of angles. Obtuse triangle should have one obtuse interior angle, but acute triangle needs all of them to be acute. This would mean there is a conflict, and the answer for number 2 is that it is false. They cannot go together. Okay. So the hint here is this. The hint is that if the classifications are of different categories, there is a possibility that the answer is true. And if the classifications are in both in the same category, thematically that's false. Let's look at number three. Number three states that an equilateral triangle can be an obtuse triangle. Okay, sir. Equilateral is according to sides. Obtuse triangle is according to angles. We have two different classification, so my answer here, sir, is true. Do not jump into conclusions immediately. I have mentioned earlier that if the two classifications belong to different categories, they may be true. I did not say they are always true. My point is this. Take note that yes, an equilateral triangle is according to side. An obtuse triangle is according to angle. So they should be true. But there is a special relationship with equilateral triangle because an equilateral triangle is also an equiangular. Again, an equilateral triangle is also an equiangular. And if we say equiangular, all the angles are of the same measurement. But if one of which is an obtuse, just like here, how can these three be equiangular? And look at their sides. If we have an obtuse, do we have equilateral? Are the sides equal? Definitely no. Because if we have an obtuse triangle, one of the three sides is the longest. So the hint earlier, again, I would like to clarify baka kasi there is a confusion. If the classifications are of different categories, they may be true, just need to analyze further. But if the classifications are of the same category, just like in number two, automatically that's false. For number three, yes, the classifications here are of different category, but the equilateral triangle is special because an equilateral angle is also equiangular and vice versa. Equiangular is also equilateral. That would mean for number two, three, the answer here is false. Let's proceed to number four. Okay, there is no equilateral or equiangular here, so we can assume the first two assumptions in number one and number two. Okay, acute is in terms of angle. Isosceles is in terms of sides. Acute angle according to sides, they may be true. Let's try to draw. If it say acute or isosceles, if we say isosceles, we have the same measurement of side. Let me make it, let me create a better one like this. Okay. So we have here isosceles triangle and all angles are acute. Okay. That would mean an acute triangle can be isosceles. The answer for number four is true. Notice that they belong on the different category. Same as number one. Number three is just special. The number three item is just very special because we are presented with equilateral, which could actually go in both directions. And number five, an isosceles. Isosceles means according to sides, right triangle, according to angles. They are of the different category, so they may be true. Let's try to draw them if they are possible. We have here a right angle, so it becomes a right triangle. And if these two sides are equal, they are isosceles. So we have here an isosceles and a right triangle. They are of different category. So the answer for number five is also true. Let me just have a short recap. In problems like this, if the characteristics of triangles are of different category, they may be true, okay? But need to examine further, especially if we talk about equilateral or equiangular. But for number two, we're in the two characteristics are both on the same category on a classification according to angles, automatically they cannot go together. So that is why in number two it's automatically false. So this is just this practice exercise needs a little bit analysis. So if you will see problems like this later on, just try to analyze if they are true or possible. If they are possible or not. If they are possible, they are true. The statement is true. If they are not possible, the statement is false. So please enjoy analyzing statements later. Goodbye.